This video is going to continue looking at Chapter 9, specifically Section 9.4, Mass Calculations. So if you remember back to our last video, we looked at going from moles to moles desired and then grams. So we can see it going across and eventually converting to grams at the end. In this video, we're going mass to mass, so we're going to start with grams, and we'll need to use our mole ratio in order to convert from our moles of known to moles of desired. This is the only way we can make this relationship. You notice that our arrows have to go down, across, and then back up again. We can't go just from grams of known to grams of desired. So let's look at an example. How many grams of HNO3 are required to produce 8.75 grams of N2O from the following reaction? And we can see here that this equation is balanced with our coefficients. So our solution map is going to go from grams of N2O to moles of N2O to moles of HNO3 to grams of HNO3. So we can look at starting with 8.75 grams because that's what's given in the equation. Here are all our molar ratios we're going to need. Our first one on the left is going to be our coefficients from the two molecules that we're discussing in the problem, and our next two are going to be the molar masses of both N2O and HNO3. So we'll start with 8.75 grams of N2O. The first thing, in order for us to use our molar ratio, we need to convert these to moles. So we'll use our molar mass of N2O. We'll have our grams cancel. We're now left with moles of N2O. We'll use our molar ratio, again with these coefficients coming from our balanced equation. Our moles of N2O cancel. We'll then use our last molar mass to have our moles of HNO3 cancel, giving us our molar mass up top, giving us 125 grams. Remember, significant figures here. So it's really important to know that for our molar mass, so our steps 1 and steps 3, always going to use our 1 mole as our coefficient. Do not use coefficients from the equation. Try and work through this one on your own. Pause the video now. Okay, how many grams of CrCl3 are required to produce 75 grams of AgCl using the following reaction? Again, this equation is balanced, so we have a little bit of our work done for us. Here's our solution map. We need to go from grams to moles to moles to grams. Here are our ratios, again using our coefficients from our balanced equation and the molar masses of both AgCl and CrCl3. So we'll start with our 75 grams given to us in the equation, multiplied by its molar mass to get those grams into moles, multiplied by our molar ratio, and then multiply again by our second molar mass, our unknown, what we're solving for, to give us 27.6 grams, again accounting for significant figures, giving us an answer of D. That's it for section 9.4.